We have all experienced that specific rising stress that comes with a cluttered interface. You open a website and are met with a dense wall of text, an unorganized settings menu, or a navigation bar that never seems to end. This feeling happens when the volume of incoming data hits a biological bottleneck. Our visual and motor systems can only map and parse a finite amount of information at once before the brain begins to struggle with the load. This limit was first quantified in 1956, when cognitive psychologist George Miller published a paper that would change how we build digital products, the magical number 7 plus or minus 2. Miller was investigating working memory, the brain's temporary scratchpad. It is a cognitive system that holds and manipulates the information needed to complete a task, right before that data is either stored in long-term memory or discarded. Miller identified a clear capacity limit. The average person can only keep about 7 distinct items in their working memory at a time. While modern research suggests that for visual interfaces, the limit is likely closer to 4 or 5, the principle of a hard boundary remains the same. When a screen forces a list of 12 or 15 options into a system with only 7 slots, the mechanic of cognitive failure begins. The new data blocks attempt to force their way in, causing the original information to be pushed out or the new information to simply shatter and disappear. This is the mechanism behind user frustration. App abandonment is often the result of a systematic failure of information processing, the direct consequence of asking a human brain to handle more data than its biological slots allow. This raises a question. If our brains drop data past 7 items, how do we successfully navigate the massive complexity of a modern e-commerce store or a music library with thousands of songs? We rely on a mechanism called chunking. This is the process of taking individual pieces of information and grouping them into a single, meaningful whole. A raw 10-digit phone number illustrates the problem. As individual digits, it exceeds our 7-slot limit. We bypass this by separating the string into smaller blocks using negative space. Now, these enclosed blocks take up only 3 memory slots, dropping the cognitive effort. Chunking isn't a formatting trick. It's a biological bypass, allowing us to manage complex data by expanding the effective capacity of our working memory. UX designers use this principle to build digital architecture, essentially reverse engineering the limitations of the human mind to make interfaces feel intuitive. A digital menu containing an ungrouped list of 15 links slows down decision-making. It forces the brain to weigh too many individual options at once, increasing the likelihood of errors and frustration. Designers solve this by categorizing those 15 links into 4 or 5 umbrella categories. As you can see in this wireframe, the chaos of the list is neutralized when the elements are grouped into a manageable number of chunks. This is often paired with progressive disclosure, the practice of hiding secondary complexity until the user is ready for it. By revealing information gradually, designers ensure you never have to process more than 1 chunk at a time. Negative space and layout groupings are not just aesthetic choices. They are technical parameters used to ensure that the data on the screen stays within our processing limits. This discipline is known as cognitive ergonomics, the science of designing systems that respect the mental boundaries of the people using them. In a world of unfiltered, raw data, a well-designed digital product acts as a filter, structuring information so it is easy for the human eye to parse and map. When an app feels intuitive, it is because a designer has already performed the heavy cognitive lifting for you. They have organized the world into chunks that fit comfortably into your mind. The most effective interfaces do not try to change how our brains work. Instead, they seamlessly conform to the biological limits of our memory.